Hello everyone. In this video, we are going to be looking into second principle differentiation. It's just a continuation to our differentiation series. And in this video, we are going to be particularly talking about second principle. Now, how do we go about second principle? Let's say we are given a function y equals ax to the power of n, as in this case. And we are being asked to differentiate this function, which says ax to the power of n. So using second principle is a shortcut procedure instead of using first principle. So the shortcuts to using first principle instead of using first principle is the second principle. And over the time, this is what we are going to be using. We're going to be using the second principle differentiation over time. Now we have y equals ax to the power of n. How do we get the y dx? To get the differentiation of this, all we just need to do is, it is straightforward. Just write the y dx equals, so we are going to be multiplying the power together with the coefficient that we have here, which is a. So the power of x is n. So we're going to be having n. So we are going to be multiplying n by the coefficient that we have there, which is a in this case. So n multiplied by a, then multiplied by the x itself. So we have x, but in this case, we are going to be subtracting the power of x by 1. And the power of x here is n. Then we're going to be subtracting 1, n minus 1. So in this case, the y dx equals a n(x) to the power of n minus 1. So this is just like a general formula to use for differentiation. So we call it differentiation with second principle. Just a shortcut to getting our differentiation done. So we're going to be looking at some examples here. So the first example, using second principle anyways. So the first example I have with me here says, so A is the first example. Says we should differentiate the function y equals x to the power of 7. So how do we get this done? Using second principle, like I told you, all we just need to do is we have the y dx to be equal to, so we are going to be multiplying the power of x by the coefficient of x, and in this case, the coefficient of x here is 1. And the power of x is 7. So the coefficient is 1. And the power, or the exponent, is 7. So exponent of x is 7. So all we just need to do is we multiply the exponent with the coefficient. So let me quickly do that. The exponent is 7. So we have 7 multiplied by 1 is still 7. Then we have x. This time around, we are going to be reducing the power, the exponent, by 1. So which is going to be 7 minus 1. So which is going to give us the y dx equals 7x to the power of 6. So this is the final answer, 7x to the power of 6. And that's how we go about it. Now let's talk about another example. So this other example, the second example I have here, says we should differentiate y equals x to the power of half, x to the power of half, as in this case. How do we go about it using second principle? All we just need to do is we have y equals, like I told you, the power here, or the coefficient here, the exponent, sorry about that, the exponent here is 1 over 2. And the coefficient still remains 1. So multiply the power with the coefficient. So we have 1 over 2, then multiplied by 1, still remains 1 over 2. Then we have x to the power of 1 over 2 minus 1. We're going to be subtracting the power by 1. So in this case, we're going to be having, sorry, this is supposed to be dy dx. We have dy dx equals that. Then we have dy dx equals 1 over 2 x to the power half minus 1 is negative half to the power of minus half. And that's how we go about this. Now let's look into the third example I have here. It says we should differentiate the function y equals 1 divided by x to the power of 3. How do we go about this? If we want to do situation like this, all we just need to do is bring this and make it look like an exponent. Turn it into an exponent. Turn it into indices. So it becomes y, we have y equals, instead of writing 1 divided by x to the power of 3, I'm going to be writing x to the power of negative 3. Don't forget, one of the laws of indices says we have a to the power of negative 1. It's the same thing as 1 divided by a. We have a to the power of negative 2. Same thing as 1 divided by a to the power of 2. We have a to the power of negative 3. Because of the negative power, it represents 1 divided by. Then we have a to the power of 3. And this is what I've been able to do here. Now let's progress. So we have dy dx now is going to be equal to, we are going to be multiplying the power by the coefficient, which is negative 3, then x to the power of negative 3, then minus 1. Don't forget, we are going to be subtracting the power by 1. So dy dx in this case becomes negative 3x to the power of negative 4. So, and this is the final answer. Now let's talk about one more exercise, which is D. It says the cube root now of x squared. To get the differentiation of the cube root of x squared. So it means y equals the cube root of x squared. Let me write properly. The cube root of x squared. So having this y equals to cube root of x squared, I need to write this in exponent form, which is going to be the same thing as x to the power of 2 over 3. So x to the power of 2 divided by 3. The laws of indices, one of them says when we have a to the power of b divided by c, when we have fractional index, it means the c root of a to the power of b. What is really happening here? The denominator becomes the root, while the numerator becomes the power. The numerator becomes the power. So the denominator becomes the root and numerator becomes the power. So we can reverse the case. So I'm reversing the case from this back to this. And that's how I'm able to get what I got. Now let's progress. So we cannot differentiate now. Now dy dx equals, now we multiply the power by the coefficient, which is going to be 2 divided by 3. That's the power. Then x to the power, then we subtract 1. 2 divided by 3 minus 1. So in this case, we have the y dx equals 2 divided by 3x to the power of 2 over 3 minus 1 is going to be negative 1 over 3. And that's the final answer. So this is how you work with second principle differentiation. And this is what we're going to be using over time. So do well to follow, to like, to share, and to comment. Anticipate for more videos like this. You are great.